Now, in order to counteract the effect of centrifugal force and reduce the tendency of the vehicle to overturn or skid, the outer edge of the pavement is, that is the outer edge of the pavement is raised with respect to the inner edge, thus providing a transverse slope throughout the length of the horizontal curve. Now this transverse inclination to the pavement surface is known as super elevation or cant or banking. Now this super elevation E is expressed as the ratio of the height of the outer edge with respect to the horizontal width. Now in practical condition or in practice, the inclination, that inclination theta with the horizontal is very small, and the value of tan theta, okay, that is tan theta seldom exceeds 0.07. So this is very much important, that the maximum value of the super elevation which can be provided is 0.07 in normal condition. Therefore the value of the theta is practically equal to sin theta. Okay, now basically, if how now we will discuss how it will counteract the centrifugal force. So basically this is the centrifugal force. It will act in this way. Now if we raise the outer surface like that, in that case, this will uh, more effectively counteract the centrifugal force in addition to the weight of the vehicle and lateral friction developed between the tire and the road surface. Now let us analyze the super elevation. Okay. Now the force acting on the vehicle while moving on a circular curve of radius r meters at speed v meter per second r, the centrifugal force equal to P, which is equal to W v square by GR, acting horizontally outwards through the center of the gravity or CG, the weight of the vehicle W, which acting vertically downward through the CG. Now the frictional force, developed between the wheel and the pavement counteractions transversely along the pavement surface toward the center of the curve. Okay, these are acting in this direction. Okay, now the centrifugal force is thus opposed by corresponding value of the friction developed and by a component of the force of gravity due to the super elevation provided. So if we consider the forces acting in the horizontal and vertical directions for the equilibrium condition, we can say that basically that is the P cos theta. So cos theta P cos theta is equal to, so if we resolve that P, here it would be P cos theta and here it would be P sin theta. So your P cos theta is equal to, that would be W sin theta, which will be acting in this direction, plus Fa plus Fb, or P cos theta equal to W sin theta plus F into Ra plus F into Rb, that is F into Ra plus Rb. Okay, now we consider the forces in vertically, then Ra plus Rb can be equal to, that is W cos theta plus, here P sin theta is also acting along this line, that is P sin theta. So if we divide this whole thing by W cos theta, and that case you will get this P by W into 1 minus tan theta equal to tan theta plus F, or P by W equal to tan theta plus F divided by 1 minus F tan theta. Okay. Now the value of coefficient of lateral friction F is taken as 0.15 for design purposes. Okay. Now the value of tan theta or transverse slope due to the super elevation seldom exceeds 0.07 or 7%, as we have already discussed. Hence, the value of f tan theta is about 0.01. Thus, the value of 1 minus f tan theta is equivalent to 0.99 and may be approximated to 1. So therefore, centrifugal ratio, or P by W, equal to tan theta plus F. Now you know that P by W equal to V square by GR. Now tan theta is basically the super elevation, that is E plus F. So your E plus F equal to V square by GR. So this is the main equation of the super elevation if we consider the V design speed as in meter per second. So if we consider V as in kilometer per hour, in that case that equation will become E plus F equal to V square by 127 R. Okay, now maximum super elevation, as we discussed, that is 7%. On hill roads it is maximum is 10%, and on urban road stretches with frequent intersection it may be necessary to limit the super elevation to 4%. And minimum super elevation is the cross slope or camber provided over there, over the road.